Vasileios Mavroeidis, welcome to the podcast.
Thank you very much. Thank you for the invitation.
Yeah, it's a pleasure having you here. You come very highly recommended. On a scale of 1 to 10, how bad did I butcher your name just now?
I think it was very good, actually.
You should.
Yeah.
How do you actually say it?
Vasileios.
Vasileios.
Greek name.
Greek name.
Yeah.
Nice. And you are a cybersecurity scientist at the University of Oslo.
That is correct.
So what does a cybersecurity scientist do at the University of Oslo these days?
Right. Basically, they do research. So I'm a cybersecurity scientist at the University of Oslo, and my expertise basically lies in two fields: cyber threat intelligence and cybersecurity automation. On one hand, I do more about I conduct more knowledge engineering for cyber threat intelligence purposes. And then we have cybersecurity automation, where my involvement is more in standardization. And this is my life every day. I conduct research, and basically our research is funded by research projects, right? And national and international, national and at the EU level.
And I'm guessing that's how you kind of like have friendships in mnemonic, is through those research projects.
Right. So mnemonic also is part of a number of projects, and they actually, I think, they used to coordinate one of the national ones, the ACT project.
The ACT project, yeah.
It's how I met people from mnemonic like 6 years ago.
Yeah, cool.
Yeah.
They say hi, by the way.
Yeah.
But security automation, that kind of reminds me of SOAR.
Right.
However you say that, right? Does what kind of products do you have around that right now?
What is cybersecurity automation? If it is to give a definition, so is it a process? Is it a task? Is it a technology? So if you ask me, it's all about minimizing human intervention in processes. So in processes that traditionally humans would conduct. SOAR platforms, as you said, security orchestration, automation, response platforms, they have been developed to support cybersecurity automation. And what do? Well, they have a pretty fancy user interface, so user experience is too important, and there you can basically encode cybersecurity processes. So when I say encode, a process that humans would conduct, now it is encoded in a way that machines can interpret it and conduct it instead of you. So our platforms are mostly commercial products. There are some open source products, approaches, but they cannot compete yet with the commercial ones. They are very sophisticated technologies, and I always say that the strength of a SOAR platform is based on the number of integrations it offers. So basically, a SOAR platform will integrate with a multitude of technologies, and when you encode those processes, because there are APIs, they are involved, all these technologies now can interact, you can execute those processes in a faster way. So what is a SOAR platform? It's an orchestrator. This is it. It orchestrates different technologies.
An extremely expensive orchestrator.
Yes.
And why do you think they're so expensive? Is it because they had to have developers make all the integrations, or what is actually driving the price tag?
Right. So I don't work for one of those companies, but I can assume immediately that, and I know from a programming point of view, that creating integrations is very expensive, and is even more expensive maintaining them.
I think that's where the price comes from. Right? They have to have people that are, every time somebody changes, that the product still works. Right.
And this is something that we can improve. If it is to direct a little the conversation, University of Oslo has identified that there is a need of going away from those proprietary communication interfaces, otherwise known as APIs, application programming interfaces, where each tool, each company, they develop their own interfaces, and by using this interface, you can command and control their tool. But all these tools have proprietary ones. They use their own syntax. They have their own data exchange models. They have their own command and control models. At the University of Oslo, we have identified that this is, it's difficult and it's expensive to create and maintain integration. So we have, we are collaborating with a number of people around the world through a standards development organization known as OASIS. And there we have a standards development technical committee that our aim is actually going away from those proprietary interfaces and creating standardized interfaces about such kind of technologies.
So if I say that in a different way, like standardized APIs or?
Right.
Yeah. And that's not like that today.
It's not like that today.
No.
It's not like that today. So if it is to talk a little more about the effort, this is called the Open Command and Control effort, abbreviated as OpenC2. So this is the OpenC2 effort. And what we do there is that we are trying to standardize those APIs. And how do we do that? I'll just give you an example, right? You have different firewalls from different vendors,
Palo
right?
Alto, Checkpoint, Fortinet. Yeah.
Right. And each one of them have developed their own proprietary interface. So basically, if we want to integrate those firewalls into your infrastructure, you'll have to create for each one of them a particular integration, and that means that you need to understand their API, the syntax that they use, and how you command and control this technology. But all of them are packet filters at the end of the day. All of them are firewalls. So what the OpenSUSE Technical Committee has thought is that, this is one function. This is what we call the packet filtering function. And why do we need to have different ways of controlling them, right? Since the capability is similar, if not the same, right? A packet filter needs to be able to allow or deny an IP or a domain. So why do we invent different ways of communicating that? Different syntax, right? So the command actually can be the same. So this technical committee, what we do there is we create what we call actuator profiles. And now the actuator is the packet filtering technology. So at the end of the day now, we can send one command and all the firewalls can understand this command. This command, would be allow this particular IP. And there are some also specifiers there, for more precision, but this is the point, right? So now when we talk about cybersecurity automation, imagine that we can remove one firewall and we can replace it with another firewall. The integration is not broken anymore. So when we talk about cybersecurity automation, we basically have to discuss about open standards, and the OpenSUSE standard, as I told you, is an open standard, and also open source tools. There are many efforts out there right now that they are trying to standardize the way we conduct cyber defense, right? Standards for data exchange, for example.
Sticks taxi, sort of. Yeah. Right.
Sticks taxi, and you reach a point that even though that the standard is mature, when you are a vendor and you have technologies that you sell, it's quite difficult and expensive, and it requires a change in the business direction to say one day, our data exchange model or our data model, our underlying data model is not good enough, and we need to change it. Or you have to create something that is going to help that. And the open source community right now, since you mentioned about sticks, there is tool that is called StickSwifter, and basically they have this StickSwifter tool that it can connect with other tools, basically CMs. And what happens is that it can query those tools, and those connectors will retrieve the information that you desire, simply stated, and then they are going to transform it to sticks objects.
So it can be shared.
Everything comes back as sticks from a multitude of technologies, those observations.
Sounds like to me there's a bunch of different standards, and that it's hard to manage them all. There's no golden standard in cybersecurity, I guess.
It's not easy to... The standards to be developed, no matter what, require a lot of effort and a lot of time. So many of them, even though that they are promising, they are incomplete. And then, if I was working for a big company that commercialized tools, I would think, well, am I going to embrace that since it's not finished? Is it going to finish?
It's a risk for them, yeah.
Right.
I noticed the other day that Palo Alto, they made a new term. Instead of CM, security, information event management, now they have something called XCM. Have you seen that?
So we have these X technologies
yeah.
right now, and the understanding is that it's more about visibility, telemetry, and the integration of analytics.
No, because I've seen a general, at least with my clients, there's a shift from detection to analysis and response. That's what customers want now. Like detection, there's so many. Detection's good now these days. If you pay, I don't know. I feel like the customers place more value on analysis and response, being able, like, for external vendors to be able to help them in those areas. Have you seen that, or?
It depends on it depends what analysis means. So we need a way to perform better decision making. So detection using the traditional means, meaning, for example, ingesting just simple observables or atomic indicators, as we call them. The context is limited. So in order to have an effective, and I'll also use the word rapid response, context is king there, right? And then by integrating also automation, since we discussed about automation, this is how you decrease attack detection and response times. I'm not sure if it covers your question, but I can assume that this is what you mean by saying analysis.
Just to figure out is this something I need to worry about or not. And that's like, right.
Situational awareness.
Back in the day, right? Mnemonic is before the word MDR was a thing, right? I mean, Argus Managed Defense is like a detection and then help you to respond tool, help you to sift through the noise and give you what's you need to actually focus on. How do you add context? How do you automate context?
How you add context and how you automate concepts, are two different things.
Yeah.
So how do you add context? Then we start talking about fusing information. We're talking about cyber threat intelligence. So it's all about analysis, what you are going to do yourself as an analyst to enrich something that you have, right? This can be the simplest thing, and I'm trying always to connect those things with automation at the same time, right? You have an observable and you want to get more information about it. What are you going to do? Well, you have to research about it, right? Maybe the simplest thing the first thing that you're going to do, if it is, let's say, an executable, you are going to push it to VirusTotal. Right, you can do this manually, but VirusTotal also offers an API. You can start creating integrations, and you can do this automatically. What about if you want to have more context, right? Open source intelligence or commercial intelligence. But if you want to start automating stuff, all this information, all this data, all this information, and basically the analysis needs to be offered in a machine-readable way. So it's not a simple process. You mentioned before STIX. So STIX is one machine-readable format that allows you to capture such kind of information. And since it's a standard model, your organization can use the same model. So when I send you a STIX feed, you know how to interpret it. STIX is a standard. It comes together with a specification. The specification will explain you exactly what are those objects that you see and how you're supposed to interpret them. Yeah. And from having the right intelligence, you can perform the right decision making. It's all about situational awareness. You need to understand what's going on. And the question is, how much can we automate? When it's about automating cyber defense, I always give the example of ODA loop. If you want to create, and as I said, automation can come in different levels of complexity, right? So for an organization that desires only to reduce the workload of the analysts, maybe they should start by automating the enriching process, right? You receive something and you want to enrich it with more information. So these are pretty straightforward and simple integrations. You're getting data, you're getting an observation, and you want to enrich it, right? So we are talking about the orientation of this information that will result then to decision making.
And that part is like that part is where that's where SOAR is probably farthest developed so far right now, is the enrichment part, right? That's like the first thing that people started to automate. Or
you can create playbooks that can go up to the course of action, right?
Yeah.
So basically, you can control whole infrastructures. You can control. You can take actions. The question is how easy is, or how effective, or how accurate is the decision making that the machine is going to conduct. So the machine may decide at some point that it's supposed to shut down, take out of the operation of a web server. Just saying, right? This web server may be the web server of that serves Amazon customers in North America, right? What's the impact, right?
Yeah.
What's the impact? Was it the right decision? So this is the reason that in decision making, humans are always involved, because cybersecurity, is critical operations, right? You cannot just leave machines make decisions. So going back to your question, there are playbooks. Playbooks exist. You can create them. If you have a robust process, and you can go from an observation that is going to trigger an enrichment, and how you understand all these data points, and then you decide how to act. So if it is to describe the cybersecurity defense to understand automation, then we would have to automate what we know as the ODA loop. Observe, orient, decide, and act. And we basically described all these things, right? Observe is an observation. It's incoming data. Orient is what do we do with this data? How do we interpret this data? So, the enrichment process will be part of it. And now that we understand the situation, there is situational awareness, there is an option of decisions that we can make. If we take the right decision, we are going to execute the right course of action. And the OpenStube, for example, technology that I described earlier, we standardizes the communication, the command and control interfaces of defense systems and components. It accounts for the acting part. So it's a language that allows you to act. Block this, allow this, query this. So now we standardize this. And we need to standardize also all the other elements in this loop. Some people also, I'm not sure if you have heard about the concept of IACD, Integrate Adaptive Cyberspace Defense. And there they are saying that the loop is sensing, sense-making, decision-making, and acting. So it's more appropriate for the cyber domain, So acting, OpenC2. So how do we standardize other steps? Machine learning plays a role, ontologies play a role, knowledge representation and all such kind of stuff. It's not, if you desire full automation, and this is something really futuristic to say, you cannot achieve that by locking yourself in vendors' products. You cannot achieve that without relying on open standards and open source tools. It's not a one solution, right? It's not a one solution.
But there's I forgot which model it was. I think Lockheed Martin or something. It was like 1, 10, 30, or it's like you detect something within a minute, you orient yourself within 10, and then you close the problem within 30. What do you know what that model's called?
I have no idea about this.
Okay,
model.
I've seen it in like a tender or whatever. But basically, customers out there say, "Okay, I want to choose a vendor that can help me detect it and close it within 30 minutes."
All right.
Which is very ambitious, right?
Yes.
And that would require a lot of data. And most of these CM systems and SOAR systems, right? At least CM systems, they charge you based on the amount of data that you're analyzing, or else everybody would have the same price, right?
Right.
And as far as I know, like a lot of the attacks that are going on these days, the way they're getting in, usually people have some sort of detection mechanisms in place. But it's always like the attackers do something somewhere that could have been analyzed, but the customers can't afford it because it's costing them too much money. So if we're going to make SOAR or, everything we're talking about, or automation work, we'd have to fix like the whole sort of commercial model around security monitoring, because you'd have to have lots of data for all this to be effective, right?
Right. So basically that's very correct. So the ICSD model that I told you a minute ago describes 3 capabilities that will allow us to reduce attack detection and response times.
Mm-hmm.
So they are saying that the use of cyber threat intelligence is too important, right? So we need to be able to use cyber threat intelligence so we can disrupt adversaries from reusing their tools, right? Then they are talking about automating the functions of sensing, sense-making, decision-making, and acting, right? And then they talk also about interoperability. Without interoperability, without having an option for the option of these tools to interconnect and interoperate, you cannot achieve that.
Interesting. Do you work with that model a lot? Is that the model you're...
Right, yes. So the University of Oslo, our group, the digital security group, believes on that.
Yeah.
So many of our researches, focus on the ICD model.
How far away do you think we're actually... I forgot. I'm going to kill myself. I don't know which model that was, but like how far away are we actually from achieving that sort of model where you can actually detect things?
Yeah.
The tools piece together and something happens within 30 minutes. Are we like 5 years away from that, or?
Well, I cannot give a time estimation. It's I see things as a science. From an operational perspective, you'll have to account for more things, right? So I can tell you that technologies exist that can help you, but then it's there are too many factors that technologies cannot are not ready to account yet. So for example, judgment. How do you make a judgment? What's the right decision? It's not simple things can be automated, right? You're receiving an indicator of compromise, and you are certain that this indicator is relevant to your organization, and you need to push it to your firewall access control lists. You can automate that, right? As long as you trust the source that shared this indicator with you. But for complex functions, humans need to be there. They need to make the final judgment. That doesn't mean that machines don't play a major role, but even those processes, the processes that the machines follow, have been developed from humans, right? We just encode them. It's what happens. So there is logic there involved, right? If this happened, then there are 2 different actions that we can take. And how do we decide that? There is again another logic there, right?
Yeah, true. Do we solve cybersecurity problem at that point then? If we've solved the automation thing, if we actually get systems that are all on the same standard working together, the logic is good, maybe people can share logic and stuff like that, but what happens then? Like then we lose our job or what?
What happens then? Adversaries are going to adapt to. So they become more sophisticated. So the question would be, can we create machines that are going to surpass the sophistication of humans? Certainly, they can do things faster than humans. But can they pass the sophistication of humans? That's science. I don't want to. I don't want to say. No. I don't want to say no. That's all.
Yeah.
But humans are smarter.
Yeah. In certain ways, yeah. Their ability to make decisions.
You need, right? So, as I said, the ICSD stands for Integrated Adaptive Cyberspace Defense. The key word here is adaptive. Can we make machines to be adaptive? Because humans are. They are going to change the way they do things. How do we teach the machines, understanding that? Because at the end of the day, now I think we're going to the topic of artificial intelligence or and machine learning. But at the end of the day, they are statistical models, right? There is no extreme sophistication underneath. How do you teach a machine to teach itself so it can become adaptive? Science, and when it's about creating commercial products, you cannot afford mistakes. The mistake that from a course of action may be even worse and detrimental than not taking an action. Maybe your mistake will cost lives. The machine's mistake, right?
Are we, by these projects and all this automation, are we actually making the problem worse just because we're introducing so much complexity to...
Very nice. So this is a very good question. So I believe that what makes the situation worse is the introduction of multiple technologies that do the same thing. And many times the newer technology is not better than the older one. And that makes the situation chaotic, especially with regards to, when we talk about cybersecurity automation, right? We need to have robust standards for threat information exchange, robust standards for command and control, etc., etc., etc. So it makes the situation worse. Embrace and extend, right? You have a research project, check. Are there any standards? Are there any technologies, open source, that they are good enough to start with and extend it? It's how I would do it.
Wrapping this up, are you optimistic of the future for, defense and being able to stop these things? You said earlier that, they're the bad guys, and obviously they're always just changing their tactics and procedures, whatever, to get to us. But do you see, is there a light at the end of the tunnel, or are we just always going to be, is there always going to be cat and mouse forever?
I think that's the situation, right? No matter what, we cannot establish enough maturity because things change, things advance, technologies advance. So new technologies, right? Scientists develop new technologies, companies commercialize new technologies, so those are new waters.
Yeah.
Year by year, day by day. So then you need to establish new maturity about new tools, new ways of doing things, right? Take, for example, COVID. All these teleconferencing systems, and now we have zero trust because everybody needs to access the organizational resources from outside. There is a learning curve there. There is always going to be a learning curve.
Yeah, and that learning curve is their opportunity, I guess.
Right. Correct. They are focused, right? And when you are focused, you are faster. Whereas, our threat surface is larger. We need to account for many things. So it's more difficult to keep up.
Well, on the bright side, that gives us things to do.
Right.
And both now and in the future.
Right.
Thank you so much for your time.
Absolutely. Thank you very much.